you know, if you miss class or if you need to go back and do something. Okay. So class is being recorded. We're going to talk about notes and superposition and interference and all that stuff. Whoa, whoa, whoa. So we're going to start off with the idea of superposition. Superposition is a very specific thing. If you shoot two baseballs at one another and they have trajectories that would cross over one another, they're just going to bounce off, right? But what superposition is, like a wave can be in superposition. They will not bounce off of one another. If they cross paths, they don't bounce. They just go straight through one another. So having those two diagrams, one where they're supposed to cross but they bounce off, and one where they do cross and it is not a problem. How could you put into one sentence the idea of superposition? How could you boil down that concept? What do you think that word means? Okay. Yeah, they won't affect one another. That's kind of like yes and no. You're definitely on the right track. You're almost there. What does the word position mean? Like, forget the super for now. What does just position mean? Yeah, where something is, its location. If I wanted to be in the exact same position, the exact same location as this desk, this is what would happen. I just displaced the desk. We cannot exist at the same position. So this one's pretty clean. I did this earlier with the flipper desk. I did with that one, and there was a surprising amount of gum. Like astonishing amount of gum under there. So physical objects like me and a desk cannot exist in the same location. So position, the position word is just location, where something is. What do you think the super part means? What's the difference between Superman and man? Yeah. What does that mean? Okay. So one has something extra. It has more than the other. Special set of abilities. So if we put those two things together, super and position, super having more in location, superposition, how could you put those two things together? Exactly. There you go. So the definition, the very simplified definition of superposition is, I don't know what that word is supposed to be. Hang on. When two or more things exist in the exact same location. when two or more things exist in the exact same location. So there are some caveats to this, as I just demonstrated. Can I be in superposition with a desk? No. So if you jump into water, can you be in superposition with the water? Does the water in you, like, when you put your foot into, okay, actually, let me quick demonstration. So if I were to be in superposition with this water, we could occupy the same space. I displaced the water. It had to get out of my way. And now I'm wet. So that's how much volume my hand is. That's Archimedes principle. Different science thing. So physical objects, things made of matter, cannot be in superposition. So that's the next note. Physical objects things made of matter. I'm putting that as a parenthetical. Cannot be in superposition. Bless you. But what can be in superposition? Yeah, waves. And all waves are energy. They're just transfers of energy. So there's actually other things that can be in superposition, like electric fields, magnetic fields, stuff like that. Basically things that are invisible to us. But one example, and the reason that we're studying it is because waves can't be in superposition. So superposition is just the general term of any time two things or more are in the same place. It doesn't have to be waves, but what we're studying it in the context of waves. So in this diagram here, the only place that is in superposition is right where they cross. Everything else is like just normal position because there's only one thing. Only where they cross and they're exhibiting, actually passing through. Okay. So real quick, just draw this diagram out, like, you know, kind of like just real basic and simple, two little humps going at one another, like A and B. Because this is just a demonstration of what superposition would look like on a wave. You have one wave traveling toward another. When they are overlapping, when they are inhabiting or existing in the exact same location, what does it look like they do? Yeah. So they're not really affected by one another. afterwards, because wave 2, it even kind of has the same general shape afterwards that it did before, and wave 1 also does. So they're not really affected by one another. They pass through each other pretty much unaffected. At the exact moment where they do overlap, do you see a difference between the waves going in and the wave where they are overlapping? What's different? Yeah. So they become one, and they're also like adding to one another. They're building on top. Their amplitudes are combining. No, no. Yeah, you can skip this stuff. Yeah, so the text written in this is from a college course. I tried to edit out as much of the really technical stuff as I could. But I just like this PowerPoint because it has lots of progress check questions and really good diagrams like this. So I was like, it's worth kind of just skipping over the technical language and just using the pictures in it. Okay. So when we have two waves that interact and that are in superposition, that specifically is called interference. So remember, superposition is the umbrella term. Anytime more than one thing is in the exact same location, whether it's a magnetic field or electric wave, something like that. Interference is specifically the superposition of waves. That's all it is. It's just a special type of superposition that we only talk about when we talk about waves. And there's two main types of interference. The first is when you have two waves that like go in the same direction, that overlap and become bigger. So we call that constructive interference. What does the word constructive make you think of? Yeah, like building. So those waves, when they overlap, they get bigger. Like their combined amplitudes is bigger than each of them individually. They build on top of one another. So when this happened, constructive interference is when two waves overlap and make a larger amplitude. So in that instance that they're overlapping, they're bigger. So on that diagram I just had you guys draw, do you think that it's this type of interference? Yeah, exactly. It is constructive interference. And you should probably go back and label it as such. Like this is an example of constructive interference. Because the waves climb on top of one another and get bigger. And you can see here that in these diagrams, it doesn't even matter what the shape of the wave is. They're always going to like combine and add on top of each other. So for example, if you had this example here is like a triangle and a square. So just to show you it all in one go, it'd look like this beforehand. They're traveling at one another. During superposition, when they're stacked on top, you would have the square and then the triangle on top. And then afterwards, you have the triangle and the square. Okay. So even if they have different shapes, it's going to come out the same. What do you think destructive interference would be then, based on that name? Yeah, so all three of you are right. Destruction, like that word means destroy. It's breaking it down, it's making it smaller. So whereas constructive building up and getting bigger, that was a little kid. Destructive interference is when amplitudes sounds really cute. When amplitudes of opposite directions cancel out. When amplitudes of opposite directions cancel out. So I'll draw an example off to the right. So we have I don't want to tell her to stop because she's being a good person. I'll keep that.
Yay! Bravo! Yay!
Okay. So we have wave A and wave B traveling toward one another. At the moment that they collide, their amplitudes will cancel out. So A is going to pull B up and B is going to pull A down. And so the overall effect is that they cancel each other out. And if you would like to put like dotted lines to show that they are in that position. And then afterwards, you have B continuing on, pretty unbothered, and A continuing on as well. Okay. So based on the little experiment that we did this morning, what would a destructive interference zone sound like?
It would be the dead spots in the way.
No, you're good. Yeah. So it is a dead spot because we're talking about amplitude. And remember, amplitude within sound is the loudness. So if we're canceling out amplitudes, we're canceling out the loud. Like one loud source and another loud source make each other quiet in certain spots. But then there were other spots that were extremely loud, which would have been yeah. Yeah, exactly. Hmm? I have so many email accounts because after a while they just get so bogged down with spam and I just keep switching accounts. It's awful. Okay. We good on this one? All right. So when you have two waves that overlap and their amplitudes sum together, what is that overall idea called? Who says A? Constructive interference. B, destructive. C, standing waves. Or D, superposition. A, B, C, D. Nice. Exactly. Yeah. So the overall idea of two things overlapping in the same spot is superposition. Oh, wow. That was quick. All right. Well, that was all we really needed to cover. These were just comprehension check questions. Have a great day, everybody. I'll see you guys tomorrow.